Hey guys, all right, today we are going to learn how to write linear equations in point-slope form. So we've spent a lot of time graphing in slope-intercept form. So quick review of that. Slope-intercept form is y equals mx plus b. And we call it slope-intercept form because within this equation we have the slope, which is m, and the y-intercept, which is b. And so you can maybe guess that the name of this form, point-slope form, tells you what we're going to have within the equation. We're going to have a point and the slope. Okay, so the slope is still the same, just like we've been talking about with slope. But the point now does not have to be the y-intercept. It could be any point that is on the line. So that's the nice thing about this form is it gives us even greater flexibility that the point within the equation does not have to be the y-intercept. And so that's what we're going to look at today. All right, so the point-slope form, if we have a point that the line goes through, which we're going to call x1, y1, okay, so that's just the x and the y coordinate, and the slope is m, which is the letter we always use, then point-slope form is y minus y1, or y minus the y coordinate, equals the slope, then x in parentheses minus x1. In other words, you do y minus the y coordinate, and then that equals the slope times, in parentheses, x minus the x coordinate. Okay, let's try this a little bit, and you'll kind of get the hang of it. So, number one, write an equation in point-slope form of the line that passes through the point 3, 2, and if it helps you, label that x and y, and has a slope of 2. Okay, so we're going to do y minus 2 because the y coordinate was 2 equals, and then the slope is 2, so that's where that goes, and then x minus the x coordinate, which is 3. And that's all you have to do. That is point-slope form right there. So there's nothing that you need to move around. You don't have to get the y by itself. That's what you did for slope-intercept form, but point-slope form looks a little different. Let's try another one. Number 2. So here we have our point where the x-coordinate is 4, the y-coordinate is -3, and the slope is -2. So on this one, it goes y minus -3 equals -2, that's the slope, and then x minus 4. Now, this is where this one can get a little tricky because we can actually make this simpler. Y minus -3, we could keep change, and just make y plus 3. And so we want to do that because we always want it to be as simple as it can be. So really, this is the way we'd like to write this equation. So what can get tricky is, notice there that the y coordinate is negative, but in the equation, we actually see it then as y plus 3 because the initial form of the equation is y minus the y coordinate. So if the y coordinate is negative, then that actually becomes y plus the y coordinate. A little confusing, I know. As we keep practicing, hopefully it'll make more and more sense to you. All right, let's try another one. Write an equation in point-slope form of the line that passes through the point -1, 4. So again, there's my x, there's my y, and has a slope of -4. So this is going to be y minus 4 equals the slope, which is -4, and then in parentheses, x minus -1. So again, there we see that negative sign. And so we're going to change it to y minus 4 equals -4 x plus 1. Again, we want it to be as simple as it can be. So minus and negative, we want to change to a positive. Now, just another side note, could we move this into slope-intercept form? Absolutely we could, but we don't need to because point-slope form is a different form. It's still going to be the same line, and I'll show you that in just a minute. Still the same line, but it's just in a different form. All right, why don't you pause the video real quick and try number 4. All right, go ahead and check your answer. Again, there with the x-coordinate, we had that situation where we have x minus -3, and we want to change that to x plus 3. Also make sure you're plugging in the y coordinate corresponding with the y and the x coordinate with the x. All right, now that we've practiced writing them, and we're going to practice writing even more later, we're going to now take a look at how we graph these. Okay, so to graph an equation in point-slope form, we're going to pull out the point and we're going to pull out the slope. So we first plot the given point. Then find the next point using the slope, and that's just like what we did. It's very similar when we started with the y-intercept and then used the slope to plot other points. Now it's just that it's not necessarily going to be the y-intercept, it's just going to be a point on the graph, but we're still going to use the slope to plot the other points and then draw a line through the points. All right, let's give it a try. Okay. So as I look at this equation, the first thing that I need to do is pull out what the given point is and what the slope is. So I always think the slope is the easiest part because, again, we see it right there before that initial parentheses. There's my slope. It's 1/2. Now, the point. Okay. Remember that the initial equation is y minus y1 equals the slope, and then in parentheses x minus x1. So in this case, the x coordinate is 2 because it's x minus the x coordinate, so the x coordinate has to be 2. Then it's y minus the y coordinate, so in this situation, the y coordinate is actually also 2. So now I have my given point, and now I have my slope. So I'm going to start by plotting the given point, which is 2, 2. Then I'm going to use my slope to plot future points. So quick review here. Slope is rise over run. So the first number tells you how much you move up and down. The bottom number, how much you move right or left. And remember, if you count up, it's positive. Right is positive, down is negative, left is negative. This is what we've talked about with slope. So in this situation, when the slope is 1/2, I'm going to go up 1, right 2. I can plot a couple points that way, or you could go down 1, left 2, and that would also work. Remember, all you have to have is 2 points. I always like to make a lot just to make sure that I can get my line precisely in the right spot. And then make a nice long straight line, put arrows on the end, and there you go. All right, now I want to show you something really quick on this one. As I told you, this is a new form, but what I want you to understand is I could move this equation into slope-intercept form and I would get the exact same line because no matter what, this equation, no matter what form it is, it corresponds to just one line. And I want to show you that on this problem. So let's take this equation, y minus 2 equals 1/2 x minus 2, and that x minus 2 is in parentheses. So if I were trying to get y by itself, the first thing I would do is distribute that 1/2. And 1/2 times -2 is just -1. And then I'm going to add 2. And I get y equals 1/2 x plus 1. And so now it's in slope-intercept form. I can see my slope is 1/2. My y-intercept is 0, 1. And if I were to graph this, I would put the y-intercept at 0, 1. I'd go up 1 over 2, and what you can see is that those points obviously are on the exact same line. So it doesn't matter if you use point-slope form or slope-intercept form, this equation corresponds to the same line. This is now just, as we say, another tool in our tool belt that we now don't have to, if it's given in point-slope form, we don't have to do all this work to move it over to slope-intercept form. We can instead leave it in this form, pull out the information we need, and graph that same line. All right, let's try a few more of these. Number 2. All right, again, I think the slope's the easy part to pull out. It's 2/3. Now, the point. Let's start with the x coordinate. So we have x minus the x coordinate, so that means the x coordinate has to be 3. But then the equation is y minus the y coordinate. So since we see y plus 2, we know this is actually y minus -2. So the y-coordinate is actually -2. And this is where can get a little confusing because you see the plus, but that actually means the coordinate is negative, and that's because in the initial form of the equation, we have subtraction. Okay, so now we're going to plot 3, -2. That's the first point. Then I'm going to use my slope to plot future points. So I'm going to go up 2 and right 3. I also could go down 2 and left 3, and I could do that a couple times to get some points on there. Make a nice long straight line, arrows on the end, and you're good to go. All right, let's try another one, number 3. All right, the slope there I actually don't see, but I know if there's not a number there, I can put a 1. So this would be -1 or -1/1 for the slope. The point, well, I see x minus 2, so I know the x-coordinate is 2. Y minus 1, so the y-coordinate is +1. So I'm going to plot that point, 2, 1. That's always the first point, is the given point. Then I'm going to use my slope to plot a whole bunch more points. So again, it's a negative slope, so I know my line needs to be falling. I can either go down 1, right 1, or up 1, left 1. But I need to make sure that one of those directions is negative. Make a nice long straight line, arrows on the end, and you're good to go. And just like before, like we did on number 1, if I were to move that into slope-intercept form, what I want you to see is that it would be the exact same line. I'll do that for you real quick. So I'm going to distribute the -1, add 1, and I get y equals -1x plus 3. So that's a slope of -1, which is the same slope we had before. The y-intercept would be 0, 3, and hopefully what you see is that's exactly the same line that you just graphed. All right, why don't you pause the video right now and try number 4. When you're ready, press play. All right, check your answer with mine. Again, notice that because it's y plus 4, I know that's really y minus -4, which is why that y coordinate is -4. So I plotted that point, 5, -4, and used 2 or 2/1 as my slope to plot other points. All right, so that's where we're going to stop in this video. You will continue watching the point slope form part 2 video to finish this lesson. Have a good day.